We're going to start off with the Pendulum lab. This is on page 20 of your lab book. So you need to thoroughly read through this and read through all the online instructions. Okay? First of all, it asks for a dowel rod because you're making a pendulum. You're going to be swinging a weight. This is how I set mine up. I just had foot surgery, so I'm using my crutch. Isn't that innovative? You need your 2 Newton or 250 gram spring scale. Now, mine came in this box that said dynometer, and I know I have the right one because there's this little sticker right here that says 2 Newton, 2.5 Newtons, or 250 grams. Okay, so that's this right here. String, and it directed you to cut it to 120 centimeters in length. Okay, you're going to need some scissors. Rubber bands are optional. A protractor, it's kind of a funny looking protractor, but this is what we have. A stopwatch, and you got one of those. Now I want to talk a little bit about the masses. They came in one big package with a whole bunch of 50 gram masses. The hook itself is 50 grams. So to make 100 grams, I'm going to add on one more 50 gram weight. And when I need 200 grams, I'm going to have 50, 50, and then 2 more to make 200. Okay? For storage purposes, so I don't end up and lose all these nice weights, I put them in a nice little snack bag like this and zipped it up, and then when I store it, it will be nice and safe and sound and I won't lose any of my weights. And I'll put these materials in it as well. So you read through the lab write-up, the lab directions, and then you print out your lab write-up, or you can do it online if you want. Number 1, write the goal of the lab or the question that you tried to answer. Well, it tells you right here in the lab itself, how do mass and string length affect the period of a pendulum? So that's what I would put right there. Number 2, which observation and experiences or lesson materials helped you form the hypothesis? Well, you've read through some lessons, and you've read through the beginning of this lab, and you have some prior experience. You need to be specific in this section. Cite specific things that helped you to form your hypothesis. Okay? So from now on, just saying the lessons, that's not going to cut it. Plus, just writing the lessons isn't a complete sentence, and you're going to get docked points. So you need to make sure that you use complete sentences, that you use proper grammar and punctuation, and capitalization. Okay? Number 3, state your hypothesis. And you need to be proposing something that's going to be happening that addresses the question. Okay? So the question is, again, how do mass and string length affect the period of a pendulum? So this is 2 different questions. Do you think increasing the mass is going to increase or decrease the period of a pendulum? Do you think that increasing or decreasing the string length will increase or decrease the period of a pendulum? And then you use the data from your experiment to complete these data tables. I got my protractor at the top. This string has been measured and is 100 centimeters long, and I have attached the golf ball to the bottom. Now, prior to that, I had to get the mass of the golf ball using my spring scale. And then I found the mass of my golf ball by hanging it off. I just hung it off using the string off of my spring scale, and I found that my golf ball was very close to 50 grams. It was 45 grams was my best guesstimate looking at this scale. And then you're going to write it in your data table. Notice that I wrote 45 grams for my golf ball, and then I'm going to start using the masses. I'm going to use 100 grams and 200 grams. Okay? And we are going to leave the length of the string at 100 centimeters. Did I say meters before I meant centimeters? 100 centimeters for all 3 of these experiments with different masses. So it tells you to pull your pendulum back to 15 degrees. So I don't know if you can see it on mine because the window's right behind it, but 15 degrees is about right here. Okay? If this is 0, looking at this, 15 degrees is about right here. So I'm going to take it and I'm going to pull it back the string back, and I'm going to hold on to the golf ball when I do this because I want my string to be nice and straight, to 15 degrees, and then I'm going to let go, and I'm going to start timing using my stopwatch. I'm going to time for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I would stop my stopwatch. All right? So you are going to time how long it takes the golf ball to swing forward and back 10 times at a 15 degree angle, and then you're going to record it right here. Okay? Then you're going to take the golf ball off, and you're going to replace it with the 100-gram weight. Mass, I should say. How long does it take for 10 swings forward and backwards? And then you're going to do the same thing for 200 grams, so you're going to add 2 more weights to this. All right? And then it asks you to plot the mass versus time for 10 periods on this graph right here. All right, so one thing to remember in part 1 of this experiment is that you don't want to change the length of the string. Okay? So the thing about when you start adding the weights onto it, you're adding this extra length. So once you put the weights on, use your meter stick and make sure it is still 100 centimeters from where you tied it onto your, in my case, the crutch, to the weight itself. So once you add the weights, you're going to need to adjust for that extra length and make sure that it's still only 100 centimeters altogether. That you pull it back stays at 15 degrees. The only thing that's changing is the mass, and then you're going to graph it. For the second part of this lab, you're still using 100 centimeters of string, and you're using 100 grams. Notice that the hanger itself is 50 grams, and it tells you that right here. It tells you that it's 50 grams. I don't know if you can see that. And then I have added 1 more 50 grams, so this whole contraption right here is 100 grams. Okay? Then you're going to make sure that the string length is 100 centimeters for the first time here. You are going to keep your string straight. You're going to pull it back to 15 degrees, which is kind of hard for me because I have a sore foot. And then you're going to let it go, and you're going to time 10 periods. So we would time 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you do that, and you record in your data table how long it took for 10 periods at 100 centimeters. And then you're going to shorten the string to 75 centimeters, and you can retie it here at the top or whatever. You're going to leave this at 100 grams because now we're looking at string length, not mass. We're going to shorten it to 75. We're going to make sure it's 75 centimeters, and then we're going to take it back 15 degrees, and we're going to time 10 periods again, forwards and back. And then we're going to shorten it to 50 centimeters, the string, and do the same thing, and 25 centimeters, and we're going to record the time for 10 periods. To make this handy-dandy graph number 2, period versus string length, and then looking at your 2 graphs, you are going to compare your data with your hypothesis. This is where you say, you know, as far as increasing mass, my hypothesis was, and if it was correct, you can say my hypothesis was correct, I know this because, and you need to back that up with the hypothesis was, and maybe it was correct, maybe it wasn't. If it was correct, you can say it was correct, and you need to explain why. Back it up with evidence.